Hello people, this is a recording of a presentation I gave for the Go Hackday in Melbourne on March 19, 2016. In this presentation I'll be talking about a Slack bot I built in Go that is running on AWS Lambda. Now, before we go into the details, a brief introduction about me. My name is Igor and I'm Dutch. Several years ago I decided to go traveling, and after a while I ended up in Melbourne, where obviously I'm still around. During my time here I got introduced to Go, and I've been playing around with it for the past year and a half or so, with some projects that panned out and some that didn't work as well. Lately I haven't really been able to use Go professionally, so I thought I would build a new project, which got me thinking that question we've all had before: what shall I build? So obviously I wanted to use Go for this. Now, another technology that I haven't really played around with before but was really anxious to try out is Lambda. So that was another thing. So I basically needed something to match these two and turn it into purpose. So for that I chose to use Slack, because that allowed me to build a Slack bot. And then it was time to do some research, so I started looking in how to make Go run on Lambda, as it's not natively supported yet. I also looked into how previously people had built Slack bots in Go, and of course how the Slack bots actually work. And it was at that last step that I ran into a slight issue, because it turns out that you need an always-on connection for running a Slack bot, which obviously, as Lambda is designed not to be always on, isn't really supported. So yeah, I did not enjoy that. As I had already started telling everybody that this was my plan, that leads to an important lesson I learned here as well, which is that before you start bragging or talking about your awesome idea, check that it's actually possible. Now, it turned out that there is an alternative way to do something like this, which is to use a Slack / command, which is basically similar in nature to a bot, except you have to invoke it specifically. Now, this is actually a much better idea. So the next lesson is you can still get away with that bragging as long as you pretend that the second choice was actually your idea all along. So instead, let's now talk a bit about how to make this actually work. Now, the main issue, of course, as mentioned, was to make Go run on Lambda. There are solutions for this though, and I decided to have a look at a couple of projects to see if they would help there. Now, the first one I investigated was called Go Lambda. There are actually two projects by this name. However, one of them requires that you set up a Node.js server to do all the deployments to Lambda and things like that, and that was just not something I was interested in. The other Go Lambda uses a Python wrapper, which seemed like a pretty good solution. However, when using it, I ran into a couple of things. First, it turned out that instead of using the default Go way of doing things, where your code goes from the main function, you needed to create a handler method or a handler function. And secondly, then you had to print the output instead of passing it along to the Python wrapper, which is okay. I could handle these two things. Because of the wrapper, it made testing locally very hard, because it just didn't work the way it expected. It was hard to call things. The last thing that I ran into though was the most important and annoying one, which is that the output, the JSON output that my application would generate, would actually be encoded again by the Python wrapper, which means that when it was sent to Slack, it couldn't handle it. And this basically meant that it was useless. Next up was a project called Apex. Apex is basically a complete application function framework for Lambda. It handles many different languages, and it seems to be a really nice project with automating a lot of the stuff that you might otherwise need. But one thing that did annoy me is the way the project structure works. So you can't use your normal Golang structure. So imagine you have your Go path set up, and you would have Go source, GitHub, Python, Igor. This is not the way that Apex would like it. So instead, Apex wants its projects into a functions directory, and under that then the function name, and in there the code. This, however, does not match with the Golang structure, and I did not feel like copying things over all the time just to upload it and test it and things like that. So that made it a bit annoying, and so again I decided that is just not good enough, and that led me to the next lesson, which is basically that all those third-party tools are nice, but they really need to completely match what you need. Otherwise, there's no point in using them. So at that point, I decided to just build my own wrapper instead. And it turned out that was quite easy. I started with a simple Node.js JavaScript wrapper. I'm not going to go into the details of it as this is about Go. And secondly, I made a small build script that cross-compiles the binary into the format required by Lambda, because Go has some awesome cross-platform compiling capabilities. It just sets it up as well, and I've got everything I need. So let's have a look at the application then. Now, first, architecture. How does it work? Now, when Slack sends a message, this is received by the Node.js wrapper that I just showed you, and that just passes it along, doesn't do anything. It's then received by main.go, but again, main.go doesn't do anything except just pass it along. This is because I'm hoping that at some point Lambda will support Go natively, and then I will just have to change main.go and not worry about anything else. Main.go passes it along to the handler. The handler does all the stuff like validation, but it also loops over all the different plugins. Now, each of these plugins are of the interface type Igor plugin, and they have some functions to return the result. When they do so, everything turns around. It goes back to the loop, the handler, the main, and all the way back to Slack. So let's look at the code then. First, the handler. Here you can see the way I'm actually looping over this. I get the list of plugins, and then I just range over it. Now, there's an actual error in this code though, something that's a result of not having used it a lot lately, and that is you cannot range over the plugin list type func map string plugins. Now, it turns out this is actually a very simple error. It just took me a while to figure it out again, and it's that I was storing the function instead of the result of the function. This is a cool feature of Go, and I'm actually using it in other places, as I'll show you later. But at this point, it was not quite what I wanted. Which in turn leads to the next lesson. Just remember how the language actually works. It's useful. Then let's look at the get plugins function that I just mentioned. Now, it's a fairly straightforward function. There's a list of all the different plugins, and it initiates a initial function for each plugin. Whether it doesn't matter much what the name is. That function does all the initialization, but doesn't actually call anything except maybe some configuration information. You can see that the get plugins actually expects a config as well. It's because what I'm not showing here is some boilerplate code for whitelisting and blacklisting plugins. Actually looking at the help function to initiate the help plugin shows you that it really is just, well, it doesn't do much. It instantiates a struct called help plugin and returns that. Okay, but then what exactly does one of those Igor plugins do? So the interface defines 4 major functions. There's work, which does all the actual work. That's why, as we saw earlier, the request is sent to, and it will handle everything, and it will either return a Slack response or a nothing found describe returns a list of everything that the plugin is capable of handling. Because a plugin can have multiple functionalities. So like the weather plugin not only listens to weather, but it can also be used for forecast. Name is a boilerplate function that just returns a short name of the plugin, and description is similar. It returns a general description of the plugin. Let's see how one of these work commands actually works. So we'll use status.go because it's an interesting one. As you can see here, I start with creating a map of functions. These functions are all of a special type. They need to be able to return a Slack attachment and error. Now, I then store all of these functions inside this map, and next up is looping over them. This is done by instantiating the function, and I do this by using the go command to enable concurrency, especially as this involves a lot of calling third-party sites to check their status. That can take a while, and you don't want to block the different results because of that. These results are then stored in a channel, and at the end just loop over the channel to get all of these results. So all that remains then is a short demo where you can see how Igor works. It's just a normal way of interacting with a bot. You can have different commands, and depending on what you type, you get the result. And as you can see here with the status, the same command can have different ways of interacting as well. So you can either check a website or a specific service. And yep. So all that remains then is to thank you for watching. You can find all of my work on my website, Ignore Me. If you want to just watch more of my videos, they're on YouTube. And the easiest way to get there is with the bit.ly URL Ignore Me videos. And otherwise, I'm on GitHub and Twitter as Arjen Swartz. I want to thank you for watching again, and goodbye.